Welcome back, class. We've learned a lot in our conversation about objects, so I just wanted to give a brief wrap up before we move on to more complex topics using what we've defined previously. So, we've been discussing a lot about OOP, so let's bring the definition to a head. OOP is a style of programming with objects creating a hierarchy through definitions and enabling the interactions between the different representations of those definitions. So, it's just objects interacting with each other. Let's not sugarcoat it. As long as you understand the difference between an object and a class and then the proper ways of using them, you will be just fine with OOP. We also have the OOP pillars, which are the key features of OOP to control resources and reduce code redundancy. Control resources through encapsulation as well as polymorphism, but we also reduce code redundancy by allowing inheritance to carry over anything that we already have defined previously. And abstraction allows us to have a general definition of things so that we don't end up getting too messy or mired in different definitions of every single object that we have. As we go forward, our discussion of object-oriented program will be used for these purposes and will be covered in later courses. We will go over algorithms with objects, the idea of interacting with a bit of data or simulating something that exists, for example, an X and Y coordinate, and then passing this data back and forth to define the movement of an object, or a searching algorithm in general, a searching algorithm in 2 dimensions or more, as well as data structures. Data structures and object-oriented programming, to me, go hand in hand. A data structure is just a way of taking these objects holding all the data and forming them in a logical way that can be retrieved for optimizing certain operations. But we'll cover that in great detail as we go forward. It's actually a favorite topic of mine, so stay tuned if you want to know more about that. As well as clean code, we're reducing code redundancy and controlling resources. We're allowing for things to be controlled in this very neat way. The ins and outs of our environment are completely under our control, so we can make sure that things are interacted with just as they need, allowing a clean entry point as well as an exit point, and reduce our code to be very efficient underneath the idea of interfaces that we can provide. And going forward, just general programming design. If you want to learn any more about any bit of ComSci, just understanding how data is organized and why we organize it as we do in OOP is important to know, regardless of never using OOP ever again. And there are many more things going on from that. I could make a video an hour long if need be, but I feel that would be boring. So let's take what we've learned together, do a review if we're rusty, and move on forward through much more difficult but satisfying topics that will make us better programmers one step at a time together. And I'm happy to cover all that and more in our time together. Just so this is known, this is a conclusion of the discussion on OOP for now, mainly doing with objects and their interactions, but the concepts that we learned will come up a lot, and I will link any relevant information from this tutorial going forward so that we can keep our definitions consistent and our learning straightforward and clean. Thank you so much for being a part of my classroom, and I hope what I've taught you helps you going forward.